years 9, years 10, years 11, that sort of thing, you'll get given questions where you have to find the surface area of a cone, and they'll give you lovely numbers, and you'll plug them into the formula and you'll solve them. In this particular case, we don't have a lovely numbers. We have a cone whose height is twice its radius, and we have to find the surface area in terms of the radius r. Does everyone understand what the question's asking? I get it. No. Basically, you're going to have surface area equals something r. That's what it means by in terms of r. Cool? So we don't want any other things in there like area or height. We just want in terms of r. So what we've got to do is, because when we have a look at the formula will have surface area equals something with an A and something with an H. Yeah? So what is the surface area formula for a cone? What was it? Pi r plus L, or is it an H? An L? Cool. Excellent. So it's slant height, not the perpendicular height. Cool. Well done. All right. So what do we do? So yeah, we're going to substitute in. Yeah? All right, so we want it in terms of r. So what are you going to do? Sorry, tell me again. Okay, so you have still got an L in there, haven't you? Do we want an L in there? You can change it. Okay, let's do that. Now, I think, Nick, you actually... Oh, I stepped on my cord and almost broke my neck. Nick, I think you said it a second ago. We want it in terms of r, so we don't want any other unknowns in there. So what unknowns have we got at the moment? We've got L and we have r, but we're happy with r. Cool? So how can we find L? Pythag. Awesome. So... Okay, so L squared equals, happy with that? Is that correct? That way? Does that look right? There's one small problem with that. Yeah. Put the brackets in. It's 2r all squared. Cool? Which equals r squared plus 4r squared. Which equals 5r squared. Happy with that? Therefore, L equals okay, can you see what I've done? I've gone, therefore, L equals square root of 5r squared, and then I was able to then find the square root of r squared. So our answer is L equals square root of 5 times r. Cool? But it's only the 5 that is square rooted, not the r. That's why there's a bit of a gap between them, so you can tell. All right? So now what do we do? So we've found L now in terms of r. This is what it means by in terms of r. We've got L equals something r. Cool? So now we sub. So we're going to go back to this formula up here and go surface area equals pi r plus, instead of L, what are we going to put in? Square root 5r. Cool? Do we need to do anything else? You could. Do we need to? Nah. You're pretty much there. What you've done is you've expressed the surface area in terms of r. The only variable we've got on the right-hand side is r. Is that cool? That's it. Because you can't solve it, and realistically, expanding it out is not going to make it any nicer. Could you factorise it any further? Take another r out if you want. So what do we end up with? I'm happy with that. I think that's actually neater. It's not what they've done, but I think that's neater. But you would not be penalised if you didn't go that step. Happy with that? Sorry? There are some. But it's the whole thing. This is the difference between preliminary, year 10, year 9 and all that. We're not dealing with numbers anymore. You remember how I kept saying to you, maths isn't about numbers? The numbers change. The numbers are annoying. They get in the way. This is a general proof. You have now expressed this as a general proof. You now do not need to know the slant height of any cone ever in this particular case, where it's 2R and R. Okay, just be aware that it's got to be in that particular case. But you know, you've now found it. So if someone said, I have a cone whose height is twice the size of its radius, but I don't know the slant length. Can you tell me what the surface area is? You can say, yeah, I can. Because you've got a formula for it in terms of R. All that you need is R. Make sense? Okay, that's what this mathematics is different to, say, general mathematics. Here, we are abstract. General, much more practical. Much more, here's some numbers, plug them in, solve it, give me an answer. Give me a solution. We want the abstract. We want the general. Which is ironic, because it's not general maths. Just saying. Everyone happy with that? Awesomeness.